Welcome to Make, Hands-on Intro to Engineering Design, a course taught at the University of South Florida. This tutorial discusses making a 3D part from a technical drawing.
Hi, this is the fourth video in the Autodesk Inventor tutorial series for the Make course. Today I'm going to be showing you guys how to make a part from a datasheet using the dimensions specified, as well as introducing one or two more new features that I haven't introduced thus far. So to illustrate this, I'm going to be drawing the stepper motor from the rotary airplane engine model that we've been using. Here's the model. I've just removed the bottom of the container here, and you can see the stepper motor here from a previous drawing. It's got the 4 screws as well as the drive shaft, and that's holding it in. You can go here to the data sheet that I obtained with this device. I purchased it through SparkFun. They gave me this data sheet, and this has all of the relevant dimensions needed to draw the motor. So let's just jump in here and start. We'll make a new part as we always do. Control N, standard millimeter part, hit create. Now we're in our new model. We're going to draw our first sketch here on the XY plane, and we're going to draw the base of this motor. So we're going to make the extrusion for this large part here. So go back to Inventor. Um, well, first we'll check out the dimensions. So this length is 31 millimeters long. And then the total width of the thing is 42.3, and it's symmetrical. So we can use those dimensions to draw this base. So because the one length was 31 millimeters, each of these side lengths is going to be 15.5. And because the overall width was 42.3, this length is going to be 21.15, I believe. 42.3, yes, so 21.15. So that's our first line. You can draw a second line here, 15.5. Go up here, draw another line. It's again 15.5. We'll dimension this 21.5 millimeters away. 15.5. So we're just making all of these lines that represent the exterior of the motor housing. We'll dimension this first. 1.15. Realize I dimensioned this wrong. 21.15. Put in our final length here, 15.5. And then now all we have to do is connect all these corners, and they will be the right angles. Okay, so there's the base of the motor. We can finish our sketch. If we go back to our drawing here, we need to extrude it 34 millimeters according to this dimension here. So we'll go hit extrude, select this sketch, look at it from the side to get a nice preview. Say 34 millimeters, hit OK. So now you can see it's starting to take shape. Sort of looks like the drawing there. So we'll continue on. The next feature we're going to include is this little disc. It's located here and here. It's 2 millimeters tall and 22 millimeters in diameter. So we're going to draw that on this newly created surface that we just made from the extrusion. Use a center point circle with 22 millimeter diameter. Correct, 22, yep, that's the right dimension. And I'm going to say finish sketch. go over here, extrusion, give it 2 mm length. So the next feature is going to be the actual shaft of the motor. It's 5 mm diameter, and it's 24 mm from this base plate here. And there's this 2 mm disc, so we'll have to remove that or subtract that distance. So it's going to be 22 mm long, 5 mm in diameter. Let's go back here, create the sketch, draw another circle, 5 mm in diameter this time. Finish that sketch. Go to extrude and say 22 mm. Hit OK. So we're getting close here. The final thing we have to add are these threaded holes. So I'm going to introduce something new, which allows us to actually create the threads on the part. So first we have to create the holes where we will have the threads. So I'm going to draw this circle. It's a 3 mm hole because it's an M3 designation. We'll dimension this, even if though it's already in the right spot, 15.5, just to constrain it, and 15.5 here. So it's constrained. We'll say finish sketch. If we go back here, we can see that the depth here is 4.5 mm. So we're going to do an extruded cut. Oops, I selected the wrong feature there. Let me cancel that. Alright, I've selected the proper sketch. We'll do an extruded cut, 4.5 mm, and hit OK. And now we're going to thread that hole. So this tool that I just clicked is the thread tool. It allows you to select a surface of a cylindrical hole or an external, if you want an external thread, a cylinder, you can select that. Once you've selected it, it allows you to go over here and specify the type of thread. So they have, unified as well as metric profiles, and they have pretty much all of the different sizes and designations you can think of. So I already have here selected size M3.05. We're going to hit OK. And now if we zoom in, you can see there's actually threads on the hole now. So to repeat this feature, we're going to use the same trick we used last time by creating a circular pattern 4 times around 360 degrees with the z-axis. But this time, when we select the features, we're going to select both the extrusion. We're going to select both the extrusion and the threads, and then we're going to make our circular pattern. So now that I have both the extrusion and the thread selected, we go here, click rotation axis, and this will allow us to select the z-axis. We pick four placements, hit OK, and now you can see we've got 4 threaded holes right where they need to be. So finally, to finish this part up just a little bit, we're going to add some other features that will make it a little bit more realistic. In reality, you don't really have these sharp edges. When I got the motor, the edges are a little bit smoothed out, and so you can add a fillet to these corners to make that a little bit more realistic. So we're going to go here and open the fillet tool, and this allows you to select edges or loops or features to add the fillet to. So right now, you can also set the radius, which is the other parameter needed for the fillet. So we're going to select a radius of 1 mm, and then I'm just going to go here and select all these edges. So as you can see, a preview pops up showing you what it will look like. You can already see that it looks a little bit more realistic with these rounded edges here. So let's see, let's make sure we got all the surfaces. You can always go back and modify it. So I think we've got all the surfaces. I'm going to hit OK. As you can see, it now rounded out the corners real nicely. So if we look back here, also you can see that there's a slight chamfer at the shaft of the motor. So we're going to add that on there. The size isn't specified, but this is more of just a cosmetic thing to make it look right. So we can do the same thing where we select the chamfer tool, and this allows us to select edges as well as the distance. So we'll go here. The default distance is 2 millimeters, but that seems to be too big. So we're going to go over and select 1 millimeter and see what that looks like. If we go over to the motor, it seems a lot better, maybe a little bit less. So that looks good. We're going to hit OK. Now we can see that the motor looks pretty good. Let's go over here and add a material to it, give it a few more properties. We'll go down here and say it's steel, and we're just going to call it plain old steel. So that changed the material slightly. I'm going to show you one last thing that'll make your models look a lot more realistic. Um, we're going to go and click the View tab, and what you can do is here they have all sorts of view styles that you can select. So just a few things to make the model look more realistic. If you want to take some images of it, for instance, or render it, you can go here and click Shadows and Reflections, and this will turn on both the shadows and the reflections, and it gives the model a little bit more of a realistic appearance. You can zoom in and see. So that concludes the portion of this tutorial, and we'll be coming back for some more here soon. Thank you.
This concludes our tutorial. Thanks for watching.